Okay, so welcome to part 2 of the video. I know you feel like there's a lot of stuff going on here, and there really is. But I'm going to bring it all back together in a few minutes to make the problem as simple as possible and as few steps as possible. So once again, we're talking about limits. Limits of value you approach as you get. It's a height you approach as you get closer to a certain x value. For here, we can see there's a limit because it's approaching the same spot. We just don't know what that spot is right now. And here we can see there's no limit because it doesn't approach the same spot. Algebraically, we proved it because we got 1 over 0, which is indeterminate, which is undefined, which means there is no limit. The limit does not exist. And over here, we put in 0. We got, for x, we got 0 over 0, which doesn't give us enough information. Now, believe it or not, we want to get this for the problem because once we have this, we actually know how to solve this problem out pretty straightforward. Okay? And you have all the techniques. I'm going to tie these things together in a minute. I'm going to bring this problem back down to here. And all I'm going to do, I'm going to write the limit as x approaches 3. On the bottom, I have x minus 3. I'm going to write it in parentheses. And on the top, because I get this as an answer, I know that x minus 3 is a factor of this particular problem. So it means that I can factor out an x minus 3 and figure out what's left. Now, how do we do that? We do it with synthetic substitution. I'm going to fill in my 3, and I'm going to fill in my numbers, which is 1, negative 5, 8, and negative 6. And I'm going to go down 1. 3 times 1 is 3. Negative 2. Negative 2 times 3 is negative 6. I'm left with 2. 2 times 3 is 6. And boom, it cancels out. When we have a problem like this, what just happened right here is going to happen every single time. And now I know what's left in the problem. Because it started out as an x cubed, it's going to be x squared minus 2x plus 2. Now, this part you guys all are doing pretty well in terms of synthetic substitution. I've now solved that out, and now I've rewritten it this way. And what I can do is I can cancel those two things out. Now I'm going to put the 3 back in, and I would get 3 squared is 9, minus 2 times 3 is 6, plus 2. Equals 5. That just tells me that where this hole is, the height of this graph at the hole is 5. The height of that hole is 5. The value isn't 5. There's no value there. But by doing this technique called limit, I'm able to find where the two sides of the graph are heading towards as time goes by. Okay, so once again, I know I did a lot of stuff here. What we're going to do is we're going to simplify it now to show you how you're going to work on problems coming up. So we're only going to work algebraically for right now. I'm not going to give you graphs. I'm just going to give you equations, and you're going to tell me whether the limit does not exist or whether the limit does exist and what the limit is. So I'm going to move this page, and I'm going to bring the work you're going to work on tomorrow, or today, whichever you prefer, in here. So there's a bunch of problems. And I'll do one of them right now, which is going to say find the limit of the following functions. If the limit does not exist, right? You can even have to write the L, DNE, for your answer, and state the type of discontinuity. So I put a little info down the bottom corner here. This is all you're going to do to figure this out. You're going to put in the number you get. If you get a number, guess what? You're done. If you get 1 over 0, you're also done. The limit does not exist. If you get 0 over 0, you'll do synthetic substitution and put in a number, and you'll be done. Seems like a lot of steps. Let's see what happens. Let's come to this first one. We'll do the first 2 here. And these 2 are due for homework tomorrow, so you can just write them down as you're going to have them. So I'm going to pause this for a second. What I'm going to do is I'm going to compute out the answers by putting in 3 into this function and putting in 3 into this function. I already know on the bottom of each function, I'm going to get a 0 on the bottom. I'm going to guess one of them is going to be a number over 0, and one of them is going to be a 0 over 0. I'm going to pause this for a moment. Okay, so I went to my calculator. I filled in 3 into this equation right here. And guess what I got? I got 0. And I filled in 3 into this top right here. And I got 1. Once I get some number over 0, I am done. The limit does not exist, or DNE, which means that this one has an infinite discontinuity. If I graph this one at 3, I'm going to see something like this. I'm going to have a line going on there. This other one, because I got 0 over 0, is going to have a removable discontinuity. And basically all the algebra you're going to do are on these two questions right here. I put in a number, I get that back, I'm done. I'm going to now take this one. I'm going to find the limit as x approaches 3, just like I was before. I'm putting x minus 3 on the bottom. I know x minus 3 is a factor because I got 0 over 0. I'll do my synthetic substitution. 3, 1, negative 13, positive 57, negative 81. Should have left myself a little more room, but 3 times 1 is 3. 3 times, negative 13 and negative 3 is negative 10. It's negative 30. Positive 27. And 27 times 3 is 81. And boom, it worked out. That's going to happen every single time. That's how you know the problem worked out. So I'm left with, I started with a third power. I'm now at x squared minus 10x plus 27. And instead of sticking 3 in again, I'm going to cancel these out. And I'm going to fill 3 into the equation, and I'm going to do 3 squared minus parentheses 10 times 3. And then we're going to add 27. And the final answer is 6. The limit as x approaches 3 is 6. Now, you don't have to do this next part. That just tells me that when I graph this, it's going to be a continuous function. But at 3, there's going to be a hole in the graph, and the height of the graph at that point is 6. Okay, so I'll have office hours. So you're going to watch the video today. I will have office hours tomorrow. You're going to be working on problems number 1 through 10 in this packet. It's these ones right here. Here's the first 2. You most likely on all of them, you're going to get a removable discontinuity or an infinite discontinuity. I will hold office hours tomorrow, and we'll go over all this together on, so today is Tuesday, video. Tomorrow is Wednesday, office hours. We'll go over all this together on Thursday, and there will be no SPQ on this on Thursday. We're going to talk about Thursday, and we're going to go from there. So 1 through 10 in the packet. I'll post this now, and I shall see you guys. I shall talk to you on Thursday.